Hi everyone, Nas here from Info.Tech.Journal. Today we're going to do another journal entry. I'm studying OSPF or restudying OSPF again, and then I found this to be intriguing, and I remember there were one case where I had to explain this to somebody, and to be honest, if you don't think about it often, you won't remember it. So what we're going to do today is specifically, as the title suggests, we're going to do OSPF. So in this OSPF, we're going to do basically two flavors of the network type for the interface for OSPF. We're going to do point-to-point. One day I do a B, point-to-point, as well as point-to-multipoint. We're going to look at the two nuances for these two types of network for OSPF, network type for OSPF, in the context of DMVPN. Okay, so that is what we're going to do. So our basic setup is going to be something simple as usual. We're not going to do anything crazy, just something simple. We're going to have 3 routers, okay, connected to some sort of underlay network. Of course, we're going to do this, and we're just simply going to hide a switch inside of this, or just to simulate our underlay network for our DMVPN. So we're going to say this is R1, R2, R2, and R3. Okay, underlay network, we're going to keep it simple. Just say maybe 10.0.123.0/24. Again, we're going to go with the 4th octet being the number of the router. So this is going to be a .1, this is going to be a .2, and of course this is going to be a .3. That's for our underlay network. We're going to have some loopbacks. Okay, so a loopback, sorry, my handwriting. So loopback 0, we're going to just have 11111/32. Similarly, here is going to be 22222, 3333. The purpose of the loopback is just so that we have extra prefixes when we actually advertise them in OSPF, just to have something extra. As for the DMVPN, we're going to have a tunnel. Let's make that a bit thicker. Yep. So we're going to have a tunnel here, another tunnel here, and another tunnel here. For all intents and purposes, in this particular video, we are going to skip IPsec on the DMVPN tunnels just to streamline it, because the main purpose of the video is just to focus on OSPF over the DMVPN and the troubles that we can actually foresee or run into when we have point-to-point and point-to-multipoint for network types for OSPF over DMVPN. So for our DMVPN, we're gonna just say, maybe we're just gonna say DMVPN is gonna be 10.1.21230/24 as well. Now that's gonna be our tunnel interface IP. Again, the same schema. This is gonna be .1, .2, and .3. So once we're gonna do that, the way we're gonna do this is, first we're gonna have this R1 and R2 for neighborships, and we're gonna see there shouldn't be any problems. From there, we're gonna add R3. That's when we'll see some problems running into the network types. And after we switch the network types from point-to-point to point-to-multipoint, we'll also see another problem because of how the network types on the interfaces have slightly different defaults. I won't tell what the defaults are right now for the fix, because that's gonna ruin the whole video, and this is another journal entry for me. So in the future, if I watch this, I want to watch the whole thing as well. Okay, without further ado, let's go into our environment. So what are the environment? Again, we have simple DNS3. Now from here, we're gonna take a router. Okay, router 1, router 2, and router 3. Okay, let's zoom in a bit so you guys can see a bit better. Or maybe not. Let's just go like that. 1 or 2 or 3. And we're gonna have a simple switch in the middle. Okay, let's just change this so you guys don't get confused, or I don't get confused as well. Let's no, not this one. That's oh no. Custom symbols, yes. Classic. Oops, let's see. Let's where's my cloud? Where's my cloud? Interesting. Where is the cloud anymore, huh? There used to be a cloud here somewhere. Interesting. They changed it. I don't have a cloud anymore. Oh. Well, no cloud is okay. I haven't used this in a while anyway. Okay, let's connect them. Connect. I just want to put a cloud there so it's better for you guys to see, or it won't confuse me as well. But then we're just gonna keep the switch default anyway. So let's start from there. We're gonna visualize this, move this to the side a bit, and let's power them on. Okay, it's powering on. Let's have R1. Give me the console of R1, R2, and R3. So where's R2? Okay, let's move here. Now we have R1. Let's check R2, R2, and R3. Okay. So R1, R2, R3. Let's just make our underlay first. Okay. Let's make our underlay. Underlay. Okay. Interface loopback 0. IP address 2. Oh, it's not 2. 1.1.1.1. 2.5. 2.5. 2.5.0. IP OSPF 1 area 0. Of course, all of them are going to be area 0. I forgot to mention that, but yeah, now I'm mentioning it to you guys and gals. So it's going to be area 0. Exit. Next one is, let's check what interface is running here. So the interface is 0, 0. Okay, interface internet 0, 0. Of course, internet 0, 0 is going to be our underlay network or our physical network. So it's going to be IP address 10.0.123.1. Okay, let's go to R2. R2 is also 0, 0. Okay. Okay. Interface loopback 1. IP address 2.2.2.2. IP OSPF area OSPF 1 area 0. It's Ethernet 0.0 IP address 10.0.123.2. Okay. If you notice that the underlay is not gonna be part of the OSPF because it's the underlay. In real world, you might have some other routings that's being done because it's not gonna be in the same subnet as what we have in the lab, but that's what we're using just to keep it simple. Interface loopback 0, IP address, IP OSPF 1 area 0. Interface is 0, IP address 10.0.123.3. Oops, sorry, this is the wrong one. Okay, and I'm saying no chat. From there, we have all the underlining IP addresses done for our physical interface. So let's just do a simple connectivity. So we're gonna say ping, and we're gonna ping the broadcast. We're gonna wait a while, and we have connectivity to 2 and 3. Again, this is our underlay. Now let's do our tunnel. Okay, from here, let's just say that our tunnel, the hub of our tunnel, is gonna be router 1. So we're gonna configure it for DMVPN. Interface tunnel 0. Okay. I'm gonna say the IP address. IP addresses for the interface is 10.1.123.1. Okay. Afterwards, we're gonna say what is the tunnel source. So tunnel source. Tunnel source is gonna be 10.0.123.1. And tunnel mode is gonna be GRE multipoint. That's our basic configuration. Now we're gonna do our DMVPN configuration, IP and HRP. We're gonna skip all the NHRP authentication. And again, just reminder, we're not gonna do DMVPN IPsec. It's just a simple DMVPN. So I'm gonna say here network ID is 1, and I'm gonna say IP NHRP map multicast to dynamic. Okay, and then say do show run interface channel 0 to show IP interface brief, exclude unassigned, and we see it is up. If we say show IP DM and show DMVPN, and let's see just interfaces. Okay, question mark tunnel 0. Okay, right now we don't have any. Of course, we don't have anybody else because the other tunnels are not done. Just to make sure that we can see it there, let's go to 2. Okay, exit interface tunnel 0, IP address 10.1.123.2. Okay, /24. Tunnel source is gonna be 10.0.123.2. Tunnel mode is GRE multipoint. Okay. The next thing we're gonna do is IP NHRP. Okay. Our network ID is 1, and IP NHRP. We're gonna map the tunnel. Okay, map. As you're gonna see here, what is the IP address of the destination? So our main hub, which is 10.1.123.1, and you're gonna see here what is the MBMA address or our underlay address. So our underlay address is 10.0.12123.1, and that is it. Okay, and then let's say IP NHRP. Now we have to say the multicast, map multicast to the underlay. You're gonna say here the MBMA address on the underlay. So it's 10.0.123.1. Again, the focus of this video is just to get DMVPN running, and we're gonna focus on OSPF point-to-point and point-to-multipoint network type for that one. And lastly, FP NHRP NHS, and we're gonna see here what is the NHS protocol IP. Okay, so we're gonna say here the NHS protocol IP is 10.0. Okay, and similarly 10.0. Okay, not 0, 10.1.123.1. Okay, that's our hub. So that should be good for basic tunnel connectivity. So we're gonna go back here, and you see here we have 1 and a D. D means it's dynamic, so that's good for router 2. So from here we're gonna say do show run interface tunnel 0. Okay, what tunnel was the number again? Let's see. Wait, not here. Sorry, excuse me. Do show run interface tunnel 0. Pretty much this is the same. We're gonna not copy everything. I'm gonna open Notepad because I'm gonna just open Notepad here. I'm gonna copy this. Okay, I'm gonna paste it in. Tunnel 0 IP address is 123.3. IP redirect, no RP and HRP. This is the same. This is the same. This is the same. This is the same. But the tunnel source is 3. I'm gonna copy this. We're gonna go to 3 and we're gonna paste it in. Let's move our away notepad. Now let's check here. Now we have both of them in. So let's do a simple ping. Ping 10 dot not 0 10.1.123.255 and we get a reply. If you notice, when I did my tunnel interfaces, I did not include them in my OSPF process yet. So let's do them now. So first, okay, interface tunnel 0, IP OSPF 1 area 0. Okay. Before we do anything, let's just confirm what is the status of our tunnel. Okay, let's confirm the status of the tunnel. Show IP OSPF interface tunnel 0. If you notice here, this is the main point. This is the meat of the project. We have interface tunnel 0. This is the IP address. It is in area 0. And then the network type is point-to-point. Point-to-point. Okay. When it goes up, it notice that is a point-to-point interface. And this is what it does. Okay. Next thing, we're going to go to R2. Okay, let's just show there's no neighbors right now. IP OSPF neighbor. Of course, there's no neighbors. There's no neighborship form. We're going to go here. This is still in the interface tunnel 0. I'm going to go there. I'm going to say IP OSPF 1 area 0. Okay, have you now you can see that it goes from loading to full, and then if you say show IP OSPF interface tunnel 0, it's the same network type point-to-point. So that works. There out of the checkbox, it works. So we go to 1. We see here loading to full. If we say show IP neighbor, we see it is now full. Of course, this one you just disregard it because the VDR is only for broadcast and non-broadcast networks. Yeah, not specifically for point-to-point or point-to-multipoint. So this won't be, we won't have any elections there. Okay. Now let's see our database, or let's say swipe it out. Swipe it out. As you can see here, now we learn OSPF, and that is the loopback for 2. That's why I included the loopback. It's just easier to verify. If we can also verify by show IP OSPF database. We have the router link state. Okay, this is the router link state 111.222. Okay, so you can see it there. Link count is 3, and so forth. Now let's go to router 3. This is where we're gonna see some problems. So we're gonna go to interface tunnel 0. Okay, interface tunnel 0, and I'm gonna say IP OSPF 1 area 0. As you can see here, loading to full, loading to full, loading to full. If you go to R1, you'll see exchange down, exchange down, exchange down. Okay, why is it? Why is it? Let's just stop here. This one here. Okay, I just stopped it so you can see. Now exchange down, exchange down, exchange down. By nature, point to point. When you listen to point, what do you think? Can there be another interface or another party trying to join a point to point? That doesn't make sense, right? Because it's point to point. So by nature, point-to-point network type for OSPF only allows for 2. When you have a third member, or a 4th and so forth, as long as it's above 2, that's when you start to have problems. That's what you start to have problems. Now, you see loading full, and let's just go put it back in. And we see that problem again. Okay. So as the fix, you would say, okay, let's just go under the tunnel. Interface tunnel 0. Right? And I'm going to say IP OSPF network type point to multipoint. Enter. As you can see now, we have now stopped receiving all these messages on our consoles. It stopped. Okay. But if you verify it, show IP OSPF neighbor, there's no neighbors. Why is that? If I say show IP route OSPF, there's nothing. Okay, if you have to do some debugs here and so forth just to find it, but then just to save time for you and me, because I already know what it is. If you look at the interface again, show IP OSPF interface tunnel 0. I want you to pay attention to the timer intervals. If you notice here, hello is 30, dead is 120, wait is 120. Just focus on the hello. If you remember, for a neighborship to form in OSPF, one of the criteria that has to match is hello timer. If you go to this interface or this router, show IP OSPF interface tunnel 0, you notice that the hello timer is 10, 40, and 40. This particularly 40, 10. So this is a hello timer mismatch for the two. So even though it stops showing you all these problems like loading to full, or start, exchange down, exchange down, exchange down, it still won't form the neighborship because there is a parameter that is not matching and they have to match the hello timer. A simple fix for this is just to go to the tunnel interface. Tunnel 0. Right, and I'm going to say IP OSPF hello interval, and I'm going to say 10. I'm just going to make it simple. 10. So when I type this, enter, we'll wait a bit, and both of the interfaces will show up, or the neighborship to form. Okay. As you can see, now it's loading to full, loading to full. If I say show IP OSPF neighbors, I have two neighbors here. If I say show IP OSPF, not database, I'll just say show IP route OSPF. As you can see here, now we have learned both the loopbacks for router 2 and router 3. So I thought this was a bit interesting, just because that you might find one thing to be the solution. Okay, let's just change the network types from point to multipoint. And then if you don't know when the default timer is for, let's say this one, if you see this is point to multipoint, the default hello interval is 30. For a point to point, the default hello interval is 10. This causes a mismatch and you won't form the neighborship. So I thought this was interesting enough to actually make a video journal and find a simple solution for it. There's multiple solutions for this, like if you were to do the OSPF over the DMVPNs, you might say it's another option would be to make it a non-broadcast network and statically include the neighbor IP addresses on the hub. That's another solution, but that's a totally different story. For this particular video, we focused on what is the default on DMVPNs when we are at the hub, or any DMVPN interface link when it's included in the OSPF process. It is by default, it will be a point-to-point. By default, again, you have to remember, in nature, point-to-point only allows for two neighbors to perform or to get adjacencies. Once you have a third one, that's when you see on the hub itself will experience start and down, exchange and down, and then you can see everything else goes from loading to full. Once you change the hub to be point to multipoint, you have to remember, and I have to remember as well, that the default timer's hello interval is different for point to multipoint and point to point. Once you change the timers, That's when everything else matches that's supposed to match for them to form their neighborship. And as you can see here, we got our neighborship and we got our routes in. So that's my journal entry for this particular video. If you're watching this and you found this helpful, just say thanks or thumbs up. Again, this is a personal video entry for myself. So if I'm watching this again in the future, thank yourself for making this video so you remember. And for everybody else, I would like to say thank you for viewing and have a good day.